Okay. So can you confirm that you see the presentation? Can you see the first slide? Is it perfect? Okay, so thank you again for listening remotely this presentation, and good afternoon, everybody. So I'm based in the UK, so here is morning, around 9 in the morning. I know that over there is afternoon, and I'll do this presentation. So I've been asked to provide a presentation, and thank you for the invitation about innovation in satellite data for geospatial intelligence. My name again is Cristian Rossi, and here I am the Principal Earth Observation Specialist at the Satellite Applications Catapult. I'll focus this presentation in four parts. So first of all, I will make a brief introduction about the Catapult, what we do, who we are. Then I will show you some examples of international projects that we carry, innovative projects, so to give you an overview of this topic. And then I focus in a specific topic that is the urban one. I'll show you how we innovate there with many examples. First of all, space is changing. So to have an independent overview is the key. And the oversight that Earth observation satellites can give is going to become increasingly important. So you have been there in these workshops since Sundays, and you have seen how the connectivity is essential. And the satellite plays an important role. So we need to know where we are, we need to know where things are. And it's within this context that the Catapult has been brought to life. So the Catapult, it's an innovation and technology research center that delivers solutions that use satellites. Satellites in both Earth observation, communication, in the broad sense. We are an independent organization, so we are backed by the government. It's a non-for-profit organization, and generally we help organizations to grow their business. Not only industry and SMEs, but also academia, so in a broad sense. And we make them discover and use in a better way satellite applications. The mission, it's general. Obviously, we are talking of innovation, and the objective is obviously to have a better world. So how we use satellites to improve lives, to improve everything. So to have a better world. So this is generally the mission. We are based in the United Kingdom, and we are independent, so we are trusted. We engage with many organizations, over 3,500. These numbers are actually of a couple of years ago, but so they're even more than that. We work internationally in many countries, and with universities in the UK and internationally. And you see some numbers here. So we raised, for instance, more than 50 million pounds in projects. So this is generally the overview. The Catapult is actually a network of research centers. So we are the Satellite Applications Catapult. And we are this red point in the middle of, in the south center of the UK. But the Catapult is actually a network of center of excellence that they focus on different aspects. So you see, for instance, we focus in cities, in energy system, in medicine, in manufacturing. That's a big Catapult. And overall, the UK, we engage with the industry locally, so through regional centers. So specifically, the Satellite Applications Catapult has 5 regional centers, and we spread more or less geographically over the whole UK. The objective, obviously, is to foster innovation and to drive economic growth. So this is the overall purpose of the Catapult, and the name Catapult implies that. So how do we catapult ideas into the market, or generally how do we grow the businesses, and how do we bring research into life? We sort of sit between university and industry, and we try to bring this into life. So as I said, space is broad. So we deal with many technology. Earth observation is obviously an important one. So monitoring, and this is one of the focus of the workshop. Communication as well. So GNSS, GPS, so to connect people, but also navigation. So to locate goods, to locate ships and whatever. We focus a lot on emerging technology, obviously, being an innovation company, and so we look into new algorithms, into new way of monitoring. So, for instance, although we call us satellite applications, we also look at drones, for instance, or local sensors. So it's a bit broader than that. The objective is actually to go and to enable markets. So here you see several examples of market, like from the infrastructure to the energy, agriculture, big one. Government, so we are a government organization, so that's a big stakeholder for us. Environment, obviously, that's climate change, everything related to that, mining, and so on. So in the next part of my presentation, I will focus in some of them to give you a better understanding on innovation with this data. I'll show you some case studies of specifically of projects that we carry. So you see Lego here, and that's so we have in the Catapult we have a team, we have a department that is called user-centric design. So when we run projects, the design and the engagement with user, it's a fundamental part of the journey. So to gather requirements and to get a full understanding on the problem, and we play with Legos. So the Lego, it's a typical activity that we give to the user to let's say to start, let's say, the journey and to sort of play with the problem. It's a design activity, and that's why you see this here. So now I will give you a sort of overview of several projects. The first one it's on agriculture in Colombia. So this is on the cacao monitoring. So this project was a project that started around 2 years ago. It's a £1 million project value, and what we try to do here is to improve the production in Colombia through satellite and manufacturing technologies. Specifically, we focus on improving the quality of cacao and improving the productivity of cacao. So you see here the group picture. So this is a project sponsored by the Newton Fund in the UK, and it's called Colco, Colombian cacao. So how can we improve the productivity of this specific crop there through Earth observation with monitoring, for instance, monitoring the suitability of land, monitoring the harvest, and so on. So this is an example. Another example on deforestation. So how can we support let's say the operational deforestation monitoring, again across the agricultural supply chain. Deforestation actually it's a broad and it's a big problem. It touches many sectors. Illegal mining, for instance, is a focus that we had, or illegal logging. This specific project, it's called Forest Mind. It's an agriculture and it's a prototype service for deforestation traceability and risk through cacao, but also other supply chain. So in this case, we work with a provider, big provider called Sainsbury in the UK, who has like a research unit. And maybe what is interesting, you see several companies here. So again, the Catapult, it's sponsoring and it's building consortium of company and universities, and all these projects actually they build the sort of community. Tea, it's another agricultural crop. It's an important one, especially in India as well, obviously, and Sri Lanka and in that part of Asia. So again, in this case, we try to use satellite connectivity and Earth observation in improving the overall chain, similar to the cacao one. So you see here in the top of the slide our approach. So really going there, doing a user research. You see post-its and so on. So it's very important to build the so-called user journey. That is what you see in the bottom, where you can see the various stage of the crop production, from farming, so with the seeding and so on, to selling and to shipping. We try to cover the whole chain, and we try to develop solutions that have specific needs. Environment protection, that's another big task. So this is a huge project called ESOS that was done in Indonesia on 3 specific aspects: flooding, oil spill, and again deforestation. It's an operational project, has been deployed operationally in Malaysia. Sorry, not in Indonesia, in Malaysia. And you see in the bottom left, like the deployment. So this has been used currently by the government for these 3 specific tasks. Climate change. Climate change is a big topic nowadays. So we have, in this case, like a huge project, 25 million pounds, if I remember correctly, on building climate resilience within small island nations. So we focus on 3 islands: the Fiji, the Solomon Island, and Vanuatu. So we are in the middle of the Pacific. And in this case, we are building well, among other things, like a data cube of SAR data and optical data that will help to task several problems, like such as coastal erosion, disaster risks, and so on. So this is again, it's a huge project on these 3 islands. Fishing. Fishing is another interesting topic and task. So this project was done in Indonesia to improve the welfare of fishermen. Again, you see the journey here, user journey. In this case, I can mention maybe a couple of outputs. So they were all based on satellite communication in this case, and not Earth observation, such as building a proper e-logbook for information on productivity, and this was helping the marketplace. So to have this sort of logbook is usually done like on paper, but we were building this electronically, but also through communication to improve the communication between fishermen and families, for instance, through text messages or fishermen and harbor and so on. So this was a communication project. Mining, tailings dams. So this is you might know that is a big task and a big problem nowadays in the mining sector, because those infrastructure that tend to they might actually collapse, and after the collapse there might be main implications, such as the loss of lives and so on. So in this case, that's a big focus of the Catapult, especially in South America. We run a project in Peru where we target several aspects, such as the stability of the dams, so through interferometric synthetic aperture radar techniques, but also general risks, like we do inundation models, or we risk analysis and risk maps, such as finding the routes for I don't know, for ambulances or so on, like everything related to a possible collapse. So this is obviously a very sensitive and important task, and satellite technology in this case can really help and support the mining sector in building what they're also called early warning system. Disaster. We have seen tailings dam, that is a human-driven disaster, potentially human-driven disaster, but there are also natural disasters, such as volcanoes, earthquakes, and so on. So this was another project in Asia, in the southeast of Asia, and where we built a response, let's say, analysis with both Earth observation and communication. So look at damages, try to find the best evacuation, the best place to build the evacuation center, and going towards this sort of analysis. Final example, it's where you're based, in Bangalore, in India. It's a project on air quality, and this project has several aspects. I don't know if you can read if the screen is large enough, but in India, as you know, there are challenges over the next 30 years linked to a predicted increase in population of the 25% that brings an increase in vehicles, so up to 450 million. Obviously, this has impact in the air quality, and specifically in Bangalore, we run this project with many partners, as you see below. The project is on the monitoring of air quality, and also in developing solution linked to that, such as I know that there is a transition in electric vehicle, or trying to get a transition. So where to put charging points, how suitable is that, or which are the roads that are most affected by air pollution. So we do this locally, putting sensors on. As far as I remember, we have a cooperation with taxi companies over there, so to put sensors on taxis, but also from satellites. So there are meteorological or optical satellites that they can measure quantities such as the PM2.5 and PM10, and we build this into the model. So this is a project that obviously it's important, and it's because it can be extended to other cities in India, but not only in India, but also in the world. You see in the map in the top left, that's a pollution map or a risk map, and you see how there are several areas of the world that are at risk. So this was just a really an overview of project to give you a flavor of the sort of project and international project that we carry. I don't know if actually you need a remote sensing recap because of the context of the workshop. I prepared a couple of slides about remote sensing, so I'll just go through very fast on that because I assume that you have already this knowledge. Obviously we are talking of monitoring of the Earth on many aspects. So you have seen in the example before how can we target, for instance, the chemical side, the biological, and the physical. We do this usually with two types of technology. An optical technology. You see an example here of a very high resolution image over Berlin. Optical technologies are very useful to build 3D models, for instance, to get atmospheric properties and the chemistry in general of the target. We can go really into the physics and into the biology, let's say, to get properties of plants and so on. So this is a technology. The other technology is the radar one. Radar are let's say a better solution in case of cloud covering, for instance, because there are limited effects, or there are even no effects due to covering, and we are more sensitive in this case to the roughness and of the target. And an important point here is that we can do very accurate measurements of distance. I show in the next part of my presentation several examples on that. How can we use radar for that? There has been an evolution here in the trend, in the resolution and in the number of satellites. You see, that is actually a not really up-to-date plot. It's up to 2015, but you see several optical sensors in the top part and a radar sensor in the bottom part. And yeah, you see how the resolution is strongly increased up to 20 centimeters, more or less, recently. This is a global technology. So obviously, we can, with satellites, we map globally the world, and this is a 2015 image of how many times, up to 15,000 times, you see, with the red, the Earth has been covered. That's quite impressive. Also, these numbers are probably doubled now, and the coverage is even more much larger, considering that this is 5 years old now. Okay, so this was like a brief recap on remote sensing. I'd like to focus on a topic that is an important one for many aspects. That is the urban one. We call this also satellite-enabled cities. So how can we build these innovation and these technologies into at the end into the user? So what we try to do here with this technology is to build information that starts from data itself and goes directly through user. The final objective is to build tool sets that are like disruptive tools that enable basically the mass consumption of this sort of data, and they must be sustainable. So they shouldn't be standalone tools. They should take into account already existing tools and already existing data. You see some examples here in the right. I will go through all of them in the next slides. Again, air pollution. So now I enter a bit more in detail with one example and what we can do. You see again a set of companies in the bottom, just to stress that this is not a Catapult alone activity, but it's a consortium activity. In this case, this was a study done in a city close to where we are based. We are based in Oxford, by the way, and this is a city called Bicester. It's just in the north of Oxford. So you see different maps here at different time of days. So these indicate the pollution level on this street. That's quite a small town. It's not a big town. We're talking of around probably a few kilometers in both sides, And those sort of maps are very, very important for planning in general, even human planning. So here people are, well, somebody is jogging in the morning. So just going outside now for jogging or bringing kids to school. So what is the optimal route? What should they avoid? How the municipality should improve the routing for human activities. So these sort of maps are very important for that. Another example on health is heat. So in this case, it's important to understand where heat waves hit. And which are the areas of the cities that are less vulnerable to heat and so on. So with satellites, we can build heat maps. So we can derive the land surface temperature of the surface. This is an example in London, and you see how there are some areas of the city that are particularly affected by heat. So this is also called heat. How it's called? I forgot. There is a name. There is a term for that. Apologies that I forgot. But it's You see basically the areas that are more vulnerable to heat. Urban planning. It's very important for the development. So where and how to build. So obviously here we go through the change detection studies and general planning. So to do that, we can build something like that. So this is also called land cover maps or land use maps, where you have a true representation on what is on ground. You can even have a representation on the type of trees. So in this case, you see coniferous versus deciduous and so on. So this is really important to plan and also to build and to understand the natural capital. So it's important for the economy in general. Infrastructure. So for the infrastructure type, this was a project done in where was it? In Dubai, I think. It was a proof of concept for road classification and using specifically deep learning. So which kind of roads and how we classify roads in general. Deep learning, by the way, is a big and machine learning in general is a big topic now in our world and is massively used to analyze data. Still on infrastructure, this was a project to find the best roofs that are suitable to be green roofs. And this project was also going a sustainable finance approach, so to quantify the economical benefits of green roofs. So where do we put green roofs? How do we select places for that? This is a quite a niche, let's say, topic, but it goes towards what is called urban infrastructure. So it's a very important one. It has been done also using artificial intelligence and finding the basically existing green roofs and using these as training and suitability for the next level. Still talking of roofs, I've shown you before how we can detect slopes and models. Obviously, you can bring this into cities and seeing the suitability for solar panel. So, what is the best location in the roof to put a solar panel? So you can build this sort of maps, as you see here, where in red there is the suitability of solar panels. This is obviously very useful for planning this sort of paneling, and it's yeah, it's something that is again feasible. Here in the UK, we have a big problem on flooding, and it's an issue that affects many cities. So it's important to use this technology, satellite technologies, to build the sort of maps. So in this map here, you see a flood score. So which are the areas that are at risk of flooding in red? Obviously, these are the areas that are closer to rivers and so on, but not only. So in this case, we use the topographical information to build this map. So important topic, and again, geospatial maps. Movements. Movements are ground movements are also a crucial aspect, and that we can do. So this is a study that I have done personally. That's maybe I can give you a bit of background. How do I start this study? I read a newspaper here that was saying that this specific city, which I don't know, it's a city in Turkey. It's called Rize. Was going to be completely relocated to another place. So it's not a big city, so the scale is in the bottom. It's around a few kilometers on the sea, because it was subsiding, and there were big risks for the population for that. When you were reading the newspaper, you were reading of buildings that they were cracking. There were stories of I don't know, I remember, for instance, a swimming pool that was keeping cracking, so the water was keeping going away, and so on. So what I've done was simply to check this from satellites and to see, is it true? So can we, well, assuming obviously that it was true, but how can we see the areas that are more at risk, and is it like in all the city? So I have taken 3 imagery from the Copernicus mission, Sentinel-1 specifically, and run this sort of analysis that is called persistent scatterer interferometry analysis over 3 years, and build this map. In this map, red points are points that are subsiding, so like going down. And you see that the problem is actually not over all the city, but is over the center, the harbor. And this was an important result. So we have given this to the municipality, and they're using now this result to better planning. If you're interested in the paper, is in the bottom. So this is just an example of using this technology for real problems. So again, I was reading the newspaper here, and I did the study. Obviously, you can use these technologies, so still on ground movement, in many other sectors. So this is an example of tunneling and the impact that tunneling has on buildings. So when you build an underground, like in this case, you can affect the surrounding houses and buildings, and it's quite impressive here to see how we can map this from space. So the accuracy here, it's on the millimetric level, so we can see displacement on the millimeter level. So it's quite impressive, and this can affect obviously the buildings through differential settlement and so on. So this study has been done by a company called Thierry, so it's in the bottom. Obviously, this can be done massively. So this is a SAR image over the city of Montreal, and this is the point cloud. So not only on specific location, but over the whole city. This is just an example. Why Montreal? Because I'll show later that we are running a project with the Canadian Research Centre on bridges. So we run this analysis to investigate bridges. I'll go better later on that. Actually, I'm going now, and I'll talk you about a bit more in detail about bridges. Bridges are important. So are important everywhere. because they're everywhere in the world, and they carry vehicles, they carry people, and they're a key infrastructure for the local economy. Unfortunately, they are subject to problems, and they need maintenance. You read sometimes here and there that bridges are collapsing. So how can we use this technology, the satellite technology, to support that? So this is how it's usually done. It's very manual, the monitoring. So people are inspecting bridges manually, filling reports. This is done every 2 years usually, but is 2 years enough? Might be not, or might be. So bridges are moving depending on settlement, obviously, but also temperature. So you see in this case in green an example of a seasonal variation of temperature. So up in summer and down in winter, and the movement is also moving according to that. You see in blue and in red the movement taken with the ground sensor. The points in pink, these are satellite measurements that they image quite nicely the ground movement. So now, how can we use this information? Thermal sensitivity is obviously an important aspect. So I'm not able to start it. Okay, this is supposed to be a video, but well, it doesn't matter. So it shows basically how the structure is like breathing and moving. And what is nice is that with this technology we can actually find how many millimeter per degree a structure is moving. Millimeter per degree. So this is the unity. We have run a project here in London on this bridge, famous bridge called Waterloo. Well, these are just some details. It's a bridge that has some structural issues, so it has been already monitored massively. It's an important bridge. If you come to London, you probably cross over this bridge. is in the city center, and it's connecting the two sides of the Thames. You see here. What we've done here was to put reflectors on the bridge on both sides, 6 on one side and 6 on the other side. They're still there. So again, if it happens to come over there, just have a look and you'll see them. And here they are. So there are those tiny corner reflector. Why did we put reflectors there? Because SAR interferometry, and that is the name of this specific technology, might need reflectors. So the measurements are not guaranteed for every infrastructure, and specifically for this sort of bridges that are like quite smooth. We ended up having very few measurements or no measurements. So we needed to install those reflectors to have a guarantee of the measurement on that specific point. So once you install those reflectors, you're sure to have a measurement over there. So this is just an overview of the SAR image. We use a TerraSAR-X stack for that, and you see those corners how they look like. So they're like those bright points in the bridge. This is one of the results. So it's a similar plot to what I've shown before. So we have done like measurements with an ATS, autonomous total station. Blue, and in pink again you see the measurements of INSAR. This is, by the way, the first ever validation of INSAR measurements on bridges. So you see how the technology is really, and we have done this like a year ago. You have seen how we are really at the beginning of a journey here, and that's quite impressive. So another problem that we studied was scouring. Scouring, it's a massive problem for bridges, because as you see in this picture, when you have scouring, so basically the removal of sediments on piers, bridges then they might collapse, as it happened here, as it happened in the UK. So where we had a collapse of quite a small bridge. It was around 100-meter bridge, masonry bridge. This was obviously in the news. No casualties, luckily, but yeah. So you see this this in the picture. A better picture here and the extent of the collapse. The point is, was this predictable? Could we do something here? We wrote a paper on that. So this is a cooperation with the University of Cambridge. If you're interested, you can find the paper in the bottom here. So these are just the collapse mechanism. Prior to the collapse, you see how the bridge was like sinking. Obviously, the bridge has been closed before that, like the night before, and then the collapse. This is the location of the collapse, so it's this point. And this is what we were able to derive with the INSAR techniques. Few points, so not many points. The bridge is small, but that red point is the point where the bridge collapsed. And if you see the evolution of that point, so we see millimeter here and time 2015, so it's like 4 years ago, and we see how it's more or less around 2 millimeter within several years. Then we start to go down at 6 millimeter the 15th of November. 9 millimeters, so that's quite a lot, 26th of November, and then the collapse in December. We don't have measurement afterwards, obviously. So this is quite impressive to see this. And what you can do here, you can start thinking to build like early warning system. So just checking this technology and these point clouds and defining simple thresholds, but not only threshold. Threshold is really the simplest way of doing it. I'll show you another way in the next example. But you see that there is something feasible here, and this is. Believe me, is highly innovative. Nobody has ever done something like that, and using this technology. And we are trying actually to engage with the civil industry world to stress this, to showcase and to try to merge their technology with this technology to bring this into life. And we are doing this with support of the National Research Council of Canada. So again, here we use some test cases in Canada. That's why I showed Montreal before, on several bridges. Here is just an example of a bridge, Victoria Bridge. It's a railway bridge. This is much longer, 3 kilometers. It's used for both railway and roads. In this case, what we were doing is, can we actually predict the movement? So can we predict how a structure is moving? Yes, we can. So we go into the civil engineering now and the structural and geotechnical engineering, but this is feasible. It's and what you see here is actually the prediction on how the bridge should move. You see several. It's sort of a zigzag here because these are all the spans of the bridge. So there are like I don't remember 20 spans or something like that, and this is how the bridge should move. Depending on the temperature. Again, temperature here is very important. And this is what we derive with satellites. So again, so from here to here, you see how the matching is quite impressive. There are some outliers here and there, but overall, the matching between satellites and prediction is quite impressive. But now, if we are able to predict and we have measurements, well, that's obvious. So this is like we're really going towards an early warning system here. And what we are doing, it's a project called Bridgital. It stands for Bridge and Digital, not a big fantasy. And it's on several phases. And we are in the second phase now, where we are building this, and we are building this early warning system to predict the risk. Obviously, there is a phase 3 that is like, how can we rank bridges, and how can we define corrective maintenance of bridges. So this will come in the future. This is a concept, and is the first ever done for this structure. Obviously, you can extend this to other structure. We are doing this for bridges, but you can think to dams, you can think to buildings, you can think to other structures. Again, it was very important, and this is linking to my first part of my talk, to talk with the engineer and authorities, because when you build a solution, you obviously need to do that. So when you need an early warning, how you need an early warning, how you need to build a system, and this has been done also for this project, and these are just a showcase. So we built a tool. So the tool is alive. You see like some points here. So those are GPS measurements that we have done over this bridge. Actually, this is showing a differential measurement. So it's a difference between two campaigns, a summer and a winter one. And you see how the bridge is actually moving differently on the two sides. We're talking of 4 to 40 millimeters, so not large numbers, and this bridge is quite dynamic, but it's something there. There is something there, and this is like without the movement. So this is the point cloud that we could derive with this bridge. Obviously, this has been done manually with an operator, and this has been done completely remotely without anything. And you see how the density is like well, it's much higher, obviously. For every point, obviously, you get like all the relevant information. And what we are building now is identify which points are problematic ones. So this, let's say, close my presentation. I focused on a specific aspect of innovation in urban, the urban one, just to showcase how this general technology can be used to innovate. And I think bridges, they are like a very nice example of that. Maybe I remove the sharing so you see me. Yeah. So I hope that this was like a sort of overview, and I hope that I gave you an impression on what my organization is doing, and many examples. One over there in Bangalore, and this was somehow fitting and useful. I don't know how to manage. If you have space for questions, feel free to ask. I asked the organizer if we have space and we can. I'm obviously happy to take any questions. Or otherwise, you got my contact that was in the previous slide. I don't know if you were able to catch it, but through the organizers, they can direct to me. So I'm happy to answer to all the questions, and I thank you for your attention.
Any questions?
Good afternoon. This is regarding the air quality monitoring in Bangalore. We are trying to deploy some nano sensors in some of these strategic points in Bangalore. Perhaps we could even collaborate actually on that. How best the satellite data and the ground-based nano sensors could be used together to identify the areas which are highly polluted in Bangalore.
Yeah, absolutely. That's absolutely a good comment. So we this project that I mentioned is a pilot project, and it's the first of this kind. And I think there is a roadmap that will go towards what you just mentioned. It's important here to understand really satellite can provide with this information. There is a ground calibration and ground factor, as you say, that is a fundamental one. Since satellites usually they monitor this at the scale of 3 kilometer up to 1 kilometer, and they need to be calibrated. So we go towards ground sensing. Yep.
Sir, one of your slides talks about the satellite-enabled cities, in which we try to integrate the satellite services with the city residents, like the heat vulnerability city, something like you talked. Have you any example in the some country which are really the whole city is managed by the satellite-enabled services?
The whole city managed by satellite, I think we are still not there, but we are building awareness. So I know the UK specifically, and we are working a lot with the London municipality. London municipality is using satellites along ground technologies to help their monitoring. But satellite alone, I would say that they are never the solution. They are the solution to some problems, but they should be integrated with ground knowledge, or at least ground knowledge, like specific geotechnical engineers and so on. So we'd like to build a world that use satellites, but also general knowledge. And this like infrastructure and this ecosystem, it's something that we're trying to build. Answering directly to your question, I think no cities only use satellite for their monitoring. They use this as an instrument to complement existing monitoring technologies. And I think this is really the way of doing it. Sometimes for very remote cities, obviously, satellites can provide like unique information, or when there is no space for satellites can absolutely be very, very useful. But in general, I think we should build like an ecosystem of services where satellites are part of it.